In many cases, we need to repeat our instructions instead of rewriting those same set of instructions. We might use the loop structures that can repeat the given instructions, and you can write anything, any type of comparison or function call statements inside the for loops. So there are some keywords that we are going to discuss. We are first going to see the for loops, break and continue statements, for else structure, nested for loops, as I discussed in some of the earlier lectures, and we're going to see how we can output some shapes using the for loops. We're going to consult to these examples in your exams and other workshops. We're going to see tuples and lists, and we are going to check the is operator, whether two instances are equal to each other in terms of entity existence. And we're going to discuss random numbers by the end of the chapter. So let's begin with these repeating instructions chapter, and we're going to go back to our turtle examples where we were drawing some shapes, some squares. So as you would remember that the turtle was moving forward for some amount of distance, and it's making a right turn, and then it's repeating this set of instructions, 2 lines of instructions, repeating it 4 times. So instead of writing these 2 lines 4 times, we can simply make a for loop. We can simply generate a for loop that can repeat them for us instead of rewriting them over and over. So here is this for loop starting with the for keyword, using a loop variable, which is an underscore, or you may name it in any other variable name, the in operator, and the range for function. So the range for function is going to return n consecutive integer numbers starting from 0 and including n minus 1, and the not n, so it's going to return n numbers. So this means that the for loop is going to receive this 0 from the sequence, assign it to this loop variable, execute these statements, and receive the second number, assign it to the loop variable again. So the loop variable's name, the value is changed. It's going to repeat these instructions. It's going to receive the third number, which is 2. So it starts with 0, 1. And finally, it's going to receive 3 from this range function. So the range for is going to return 0, 1, 2, and 3. So the loop visits all these numbers, and for each of these numbers, it's going to execute these 2 lines. As soon as it exhausts this list of numbers, the loop is over, so it is executed only 4 times. Let's open the example. So we have the same square drawn by less number of lines. So you can also rename this to be my line counter Okay, you can give them any name, any variable name, any valid variable name, and use it inside your iteration. So I need to display current line is line as line counter, and you can now trace that the values returned by the range function are 0, 1, 2, and 3, as in this case. Okay. Now if you want to draw more lines, like polygons, let's make a pentagon, and I think we should set this as 72, and let's execute this code once again. Now we have this pentagon. I haven't inserted any repetitions of these codes, of these lines. If I had these lines, as in the earlier examples in the previous lectures, you would remember that I would first have to replicate these two lines, and then I would have to change these values to 72 instead of 90 degrees. So I have added 2 more lines to my code and modified 5 lines, and this is the same, this has the same effect. If I wanted to make it a hexagon, I would then modify this to be 60. For doing it in the sequential coding, I would now have to modify 5 lines with an additional 2 lines. Okay, now I would have written it as 60. So this goes on and on, but in here I can make any polygon, such as, let's make it a polygon that has 20 sides, so the turning angle would be actually 360 over 20. So I wouldn't have to repeat these 20 times. Instead, my code simply uses the same sequence of statements, only 2 of them is sufficient to draw any polygon I need. So I can make it even, let's move less amount, so I have 50 here. Now if I try to execute this code, it's going to draw me this polygon with 50 edges. And I can also assign this value to be 40 and use this as a parameter to the range function, which receives integer values, edge count. Now I can use this edge count as edge count to calculate the turning angle. And when I run this, it's going to draw a polygon that has 40 edges, or you can make it 4 to draw a square, a small square, but still a square. So let's make it 30. Run it. So you can now draw multiple shapes using the same sequence of instructions. This is one of the powers of the for loops, using loops for repetitive actions. Okay, in our case, we wanted to do this action 4 times or n times. So we don't make use of this line counter in our actual job. We just output the current line, but we don't need it. So it is not necessary. But although it's not used inside the for loops body, so this is the body of the for loop. Although it's not used, it's not necessary, we still have to specify something here, some variable here for the correct behavior of the for loop. Otherwise, it wouldn't execute. So this is why you can simply use this. Also, the value assigned to that variable is not important. You can use a list of 4 numbers, any 4 numbers, just to repeat the for loop itself. So you can give it a list if you are interested in drawing squares. 4 numbers is sufficient. But if you have a variable number of edges in your shape, you need to specify this range function so that it returns as many numbers as required for your for loop to iteratively repeat the contents contained in the for loop's body. As in this case, we have these 2 lines. This is the first line, this is the second line. They are included in the for loop due to this indentation, and they're executed as many times as the list returns, as many times as the number of numbers in that list returned by the range function. But this structure here is called a list, so it's defined in between the square brackets. Don't confuse it with the access operator that we used for the dictionary, the Fibonacci dictionary. You would remember Fibonacci dictionary. We would provide a key and we would get a result, or we would assign some value to this Fibonacci if we had this on the left hand side. If we had it on the right hand side, we would be retrieving the value and assigning it to the result or the value part. Okay. So this is different than this one, although they are the same set of operators. The meaning is different. In this case, we are defining a list using a pair of square brackets. You can also identify the sequence that's going to be returned by the range function by providing lower limits and upper limits. So it's going to start from 20 and go up to 29, and it's going to return 10 numbers. So this upper limit is going to be excluded from the sequence. It's going to return numbers that are increased by 1. But if you want them to be increased by any other number such as 2, you may also specify that. So this range function call here, range 20, 30, 2 is going to return 20, 22, 24, 26, and 28. It's not going to return 30. So these are some uses of the range function that you can experience, and you can output their result. Here in this case, let's just print range, let's say 10, and 100 by increments of 15 before we start our code. And when we execute this code, range. It returns the execution of this list. So if I write it like this, okay, now let's try this once more. Now it has output the result. It was stuck at some point. And if you don't have this list constructor, it returns the definition of the range function call. So this is let's say a different behavior. So if you want to print the outcome of the range, it just returns it as a structure. But if you want it to be displayed as a list, you can use the list constructor that generates the sequence of numbers for you, and you can display that list. But if you use it in this for loop structure as the range, okay, the entity returned by the range definition, the range function call, is iterated, and each value 10, 25, 40, 55, 70 and 75 are assigned to this line counter one by one from here. So the values are actually from here to this one. So it receives 10 initially. If I were to, let's say, take it like this, let's make another for loop. For my loop variable to be in range 10 to 100 with increments of 15. Okay, now I can define my loop. I have to end it with the colon, as you might have already noticed. So this variable in the loop definition is going to receive the values 10, is going to receive the value 10 for the first cycle of the loop. Okay, and it's going to receive 25 at the second cycle of the loop and 40 at the third cycle of the loop. So whatever is returned by this range function, they're going to be assigned to the loop variable one by one. So at each iteration, it's going to receive only one of them, starting from the beginning, which is 10. And at the second iteration, when it completes this print statement, so when it completes the execution of its body, in this case it completes these two lines, in this case it's only one line, it goes back to this loop and checks whether there are any more items that can be assigned to this loop variable. If so, it executes this line. If all the values are exhausted, so if 85 was assigned in the previous loop, it goes back and checks if there are any other numbers left. No, there are no numbers left, so it just doesn't execute and continues with the next statement. So we have already drawn polygons using our for loop. You have the example here that you can assign the sides and calculate. And you can simply receive the number from the user using this input function, and you assign that value after converting to an integer to your variable. Okay, you might try to draw some dashed lines, so you might use the pen up and pen down functions. So in this example, you can use the drawing shape function to make this shape of rings. Okay, it's not that complicated actually when you look at it, and when you analyze the code, it just sets some, initializes some values and then calculates some turning angle. So our turtle is actually drawing this line, this circle, sorry, starting from this point, it's drawing this circle and it's making a small move, and it's drawing another circle with a different angle, and it's making another small move and drawing and making another small move. So this is the solution to this specific problem. So it's actually moving along a polygon. So it's moving like this, this, and everywhere it moves, it's making a circle with different colors. So it's not that hard. You can easily grasp the idea. So there's this number of edges to be drawn, but instead of drawing those edges, we use the pen up function so that we don't draw anything on the screen. So if we don't do it, let's just comment these pen up and pen down parts and rerun our code. We're going to see that it's actually making these polygonal drawings here. How about decreasing the number of edges we have? Let's just close this, and count is 5, and let's rerun this. Okay, now you can see that it's making this radius over 10. So edge, let's fix this to be 100 so we can see our edges. And let me turn this off, rerun this. Now we can see the edges. Okay, actually what I was doing is that I was drawing a polygon, but before moving I was making this circular shape and moving to the next point and making this circular shape and moving to the other point, making another shape. So what it does is it's actually traversing our polygon and making circles at the corner points. So according to its alignment, the turtle's alignment, which is to the right at the moment, it's drawing this one. When we move the turtle this way, it's aligned to this direction. Okay, so it makes a circle like this. When it's moved to the next position, it's aligned to this direction, and it's making another circle. So this is a tricky example, but it's simple, and I think it's very nice to understand the complexity of our applications. It might seem very hard at the first glance, but actually it's not that hard. Please do experiment on this example on your own, so you can come up with other ideas. You can also make different shapes, and it's a good practice. You can also have other for loops inside your for loop, so you can make different shapes instead of circles at the corner points. And probably you might end up with a fractal geometry if you insert some recursion in your corner point evaluation. So if I, for instance, go back to this, let me just restructure it back to us, so you're going to understand what I meant by fractal. So everywhere you go, you might want to draw this pentagonal shapes. So instead of generating circles, you might want to generate other pentagons like this. I cannot draw like this one. Okay, there is a pentagon here, but at the corners of these pentagons you might also want to generate other pentagons. Okay, like this. Okay, and at the corners of these pentagons you might also want to have other pentagons. My pentagons are very ugly, but tiny pentagons would look like fractal geometry. You can achieve this by using either for loops or recursion. For those of you who are interested, there are multiple ways of doing this, but at some point your program has to return to the code. So if you go by recursion to this one, from here to this one, and start drawing the first edge and start with the smaller pentagon, and at the corners of those smaller pentagon, if you continue, you would never end this shape. So you have to be careful. You first generate the first level pentagons, and then you go to the second level pentagons, and then you go to the third level pentagons, etc., etc. So this is for the curious. Okay, let me just find how to exit this part of the code and clear this mess up and continue with the next part. So if you want to draw a dashed circle, we have this example for you. At each step of your circle, you have to make a turn of 180 divided by the number of dashes, because you make 2 turns at the same time, which completes the entire turn into 160 degrees. So when we run this, you're going to see that it's expecting the number of dashes to be, let's say, 10. I'm going to try finding this. Here we have 10 dashes and some gaps, dashes, gaps. So you can increase the number or decrease the number. So you have a dashed circle. Again, using the for loop, it repeats this process as many times as the dash count. And from here, we can move on to the details of for loops in the next part.